Hello and welcome to my project. I had 3 goals for this project. 1. Make an object float steadily. 2. Use the lowest cost components and build as much as I could. And 3. Create a system that learns. One challenge I liked about this setup is this is a dynamic system. A steady airflow will not keep the height steady. There is randomness from turbulence and airflow rotation. Let's talk about some interesting aspects of the code. I use Python since it is fairly straightforward to do simple things like this project. This portion of the code sets up the Pi to control the sensor. The Pi sends 10 microsecond pulses to the sensor and estimates the distance based on the time it takes for the pulse to get back. Next is estimating position, velocity, and acceleration of the object. Now this was a challenge. The sensor error is about plus or minus an inch, and this error impacts greatly the estimates of velocity and acceleration. Calculating statistics from many readings will decrease the error. The issue is, after all, this is a low-cost sensor and it overheats if too many measurements are taken too fast. In other words, you have to balance accuracy and reliability. So next, let's take a look at controlling the fan itself. Controlling the fan is pretty cool. This 4-wire fan is controlled by modulating the pulses sent to it. In other words, pulse width modulation. The fan also sends back to the Pi a measure of how fast it is turning. Another interesting piece of the code is how it learns. The first level of learning determines more or less how much airflow is needed to start levitating the object. The second level of learning starts tweaking the airflow to make the object float to the desired level. It is looking at how far it is from the height goal and the velocity and adjusts accordingly. The third level of learning looks at the measure of error during the past 10 cycles and tweaks the degree by which the second level of learning adjusts. Now let's take a look at the system in action and I'll highlight when it is learning each level. Let's run the system. Initially, it increases airflow until the object starts floating. Once it determines at what airflow level floating starts, it starts tweaking the second level. The third level of learning happens every 10 cycles as it estimates how much off the height goal the object is on average. Now some people stress that the Raspberry Pi is not recommended for critical real-time control. In this case, I am not sure if it is the Pi or the sensor, but sometimes pulses are lost which cause errors. I accounted for as much of this as I could, but either the Pi missing pulses or sensor error throw the system completely out of whack, at which point you just have to let the system adjust back by itself and learn again. So let's take a look at how the system recovers. After a few cycles, the system recovers. No manual intervention needed. So at this point I thought, what if I throw a different type of object? Would it be able to learn, adapt, and keep the height required? Let's take a look. I found a leftover balloon from a kid's party and wondered how it would work. It actually worked out great. The balloon is half inflated, so the rubber is soft and spongy. The balloon dampens the effects of the rotation and turbulence of the airflow. In other words, it is just easier to control. I hope you enjoyed this video. I really enjoyed building this and learned quite a lot. Thank you for watching and I hope you enjoyed it.